You know, picking a software architecture is one of the highest stakes decisions you can make in a project. If you get it right, you are setting your team up for success for years. But if you get it wrong, well, you'll spend all that time just fighting your own system. So, how do you make this choice with confidence? Let's build the framework to do just that.
So this is the classic question, right? The one that keeps architects and lead developers up at night. You're kicking off a new project. The buzzwords are flying around: microservices, serverless. Everyone's got an opinion, and the pressure is on to pick the right one from day one. But is there really a single best choice out there?
And there it is, the answer we all know and, well, love to hate. It depends. It's cliché for a reason, because it is 100% correct. There are no silver bullets in architecture. But let's be honest, just hearing "it depends" with no explanation is totally useless.
Right. So what does it actually depend on? That's what we're going to unpack. We're about to break that super vague answer down into a concrete, step-by-step process you can actually use. We're going to put some real structure around "it depends."
Okay, so here's our game plan. We'll start by digging into why we have this "it depends" problem in the first place. Then we'll get into your core decision criteria, figure out that big monolith versus distributed question, talk about finding the right fit, and wrap it all up with choosing your trade-offs.
All right, Section 1, Architecture's "it depends" problem. So why can't we just find the one perfect architecture and just call it a day? Well, it's because the entire landscape of software development is constantly shifting under our feet.
See, these architectural styles, they aren't just fashion trends that come and go. They're actually reactions. We feel the pain from one approach, and a new one pops up to try and solve it. Think about it. New technologies like open source and new practices like DevOps made entire patterns possible that were just a pipe dream before. We even reevaluate things we once held as absolute truths, like reuse all the code, when we discover the painful side effects like components that are way too tangled together.
And this right here is the perfect example. Imagine trying to pitch microservices back in, say, 2002. You would have needed dozens of separate, super expensive proprietary licenses for everything. You'd have been literally laughed out of the room. But today, thanks to open source, it's a completely normal, feasible option. Context is everything.
Okay, so on to our core decision criteria. If the right answer always depends on context, then we need to know what parts of that context to analyze, right? Let's build that decision-making toolkit.
It really boils down to 4 key steps every architect should take. First, you've got to understand the business problem inside and out. Then, from that, you identify the system's required operational qualities. After that, you check how well an architecture's shape fits your problem's shape. And then finally, you make that fundamental choice: monolith or distributed. Let's dig into each of these.
Whoa, okay, this chart looks a little intense, but the idea behind it is actually pretty simple. These are your architecture characteristics, or what a lot of people call the ilities, like scalability, performance, testability. They're not about what your system does, but how well it does it. Think of them as the promises your system makes. How fast is it? How secure is it? Getting these right is every bit as critical as building the right features.
And this is so important. Your goal as an architect is not to build a system that's perfect at everything. That's impossible, and it's a recipe for a bloated, complex disaster. No, the real art is working with your stakeholders to identify the top 3, maybe 4 most vital characteristics, and then you focus the design entirely on supporting those. Every single illity you add has a cost.
So, with our key characteristics in our back pocket, we can now tackle the first major fork in the road. Do we build one big thing, or lots of little things that talk to each other?
At its heart, this distinction is really simple. A monolith packages and deploys everything as one single unit. A distributed architecture, like microservices, breaks the system up into multiple independently deployable units that communicate over a network.
So how do we actually make the choice? Well, the secret is in this concept called the architecture quantum. Now, it's a bit of a mouthful, but think of it like this. A quantum is a single piece of your system that can be deployed all by itself. It has all its own gear: the user interface, the logic, the database stuff, everything it needs to do its job. It's a self-contained, independent piece of your system.
And this idea makes the decision so much easier. If your entire system can operate successfully with a single, unified set of characteristics, meaning you only need one quantum, then a monolith is a great, simple choice. But if different parts of your system have conflicting needs, like your user catalog needs to scale to millions, while the payment service needs extreme consistency so you never lose money, then you have multiple quanta.
and that means you require distributed architecture to support each of those needs independently.
Okay, so you've made the big call between a monolith and a distributed system. But that's just the first step. Now we need to find the specific style within that category that best fits the shape of our problem. There's a fancy term for this, domain/architecture isomorphism. It sounds way more complex than it is. It's an incredibly intuitive idea. It's basically asking, does the structure of your architecture naturally mirror the structure of your business problem? You want a solution that feels natural, not forced.
And here is a perfect example. Look at this diagram for a bidding system. You have a bid capture service, a bid streamer, and a bid tracker. These are all separate, independent business tasks. A microservices architecture mirrors this perfectly by creating a separate, independent service for each of those jobs. The shape of the architecture just naturally fits the shape of the problem.
But what happens when there's a mismatch? Imagine modeling a complex, multi-page insurance form, where every single field on page 5 depends on answers from page 1. That business problem is highly coupled, but an architecture like microservices is highly decoupled. You would spend all your time fighting the architecture, creating constant friction and needless complexity. It would be a nightmare.
This brings us to the final, and honestly the most important piece of this whole puzzle. There is no perfect architecture. Every single decision you make is a compromise.
This quote is really the soul of software architecture. Your job isn't to find the best solution, because it just doesn't exist. Your job is to understand all the competing concerns and then choose the set of compromises, the least worst collection of trade-offs that best serve the specific needs of your project. And this table makes those trade-offs crystal clear. A layered monolith, you get 5 stars for simplicity and cost, but only 1 star for scalability. Need massive scalability? Well, an event-driven architecture gives you 5 stars there, but you pay for it with 1-star simplicity. You can't have it all. You have to choose what you're willing to sacrifice.
So, let's wrap all this up. First, just accept that the answer is always it depends. Second, base your decision on the business domain and the few critical abilities you need. Third, use that concept of architectural quanta to make that first big monolith versus distributed cut. Then, find the style whose shape fits your problem. And finally, always remember, you're not looking for a perfect design, you're looking for the least worst set of trade-offs.
So the next time you're faced with this choice, don't ask which architecture is best. Instead, use this framework to analyze your context, understand your priorities, and answer a much more powerful question. For this specific problem, what is the least worst decision I can make?